In this video, we are going to derive the area of a circle, which is pi r squared, using the trigonometric substitution method. So we shall begin with a circle. Remember, the area of a circle is just a circle, and divide it into 4 parts. That is the y-axis and the x-axis. The x-axis, we shall shade this region because we're interested in one of the region, that is from 0 to a. Then we also have here negative a. We have b, which is negative. Then here is b on the y-axis. Now, this is our required region. Let us label it a. Now, we must define an expression that will help us to derive this pi r squared, which is the area of a circle. And we shall start by x squared all over a squared. We are relating x-axis with a, which is the distance from the midpoint to here, which is later the radius of this circle. Then we shall add y squared over b squared, which is equivalent to 1. So from this expression, we shall make y squared over b squared the subject of the formula, and that will be y squared all over b squared. We shall take this on other side and become 1 minus x squared all over a squared, which is equivalent to a squared minus x squared all over a squared. So from this, we shall now have y squared over b squared, which is equivalent to a squared minus x squared all over a squared. Now, from here, we will multiply by b squared each side to remain with y squared alone, times b squared multiply by b squared. This will cancel this, and you will remain with y squared, which is equivalent to b squared all over this a squared will come this way, then multiplied by a squared minus x squared. From there, we shall find the square root so that we remain with y alone. So the square root on this side and the square root on the left side. This will be y, which is equals to b all over a, but since it is the square root, we shall have positive or minus, then the square root of a squared minus x squared. From here, we have a defined expression, which now we can relate it to our equation of trigonometric substitution. And for this case, if you remember in the last video, I told you if it is a squared minus x squared, this will be related to x, which is equivalent to a sine theta. This is a trigonometric expression for substitution method. Then from there, we shall now have our area. We are interested in the area, and to get the area of any given region, we use integration. We integrate from 0 to a, yani from 0 to a. That is now our area, which is equivalent to now b all over a, then square root of a squared minus x squared dx. From there, we now find from our expression of trigonometric, we now find dx sine theta. Then dx, as we all understand, dx of sine is cos. It will be a cos theta. Now, we have dx and we have x. We now replace them in our expression, and we shall have area, which is equivalent to But remember, our target is to locate this area, which is a quarter. This is a circle. Now we're interested in this part alone, which is a quarter of the area. Sorry for that. That is a quarter of this area of this circle, first of all. So we shall have B all over A from 0 to A. Now replace x with A sine theta. And we shall now have A squared minus, remember x is squared, now we shall square A sine theta and have A squared sine squared theta, then dx with A cos theta. Here there is a multiplication sign. So from there we can now have a direct expression, which is 1 over 4a, which is equivalent to b over a, integrating from 0 to a, of what? Factor out a squared, then have 1 minus sine squared theta multiplied by a cos theta. It is d theta because we are finding the integral of that part to find the area. So from there we understand from the double angle formula that 1 sine squared theta is equivalent to cos squared theta. Now replace here 1 minus sine squared theta with cos squared theta, and you will find 1 over 4a, which is equivalent to b over a, integrating from 0 to a, square root a squared, but now here is cos squared theta multiplied by a cos theta d theta. Let us move to the next page. Now we have 1 all over 4 area, which is equivalent to b over a, integrating from 0 to a. Now our expression is now the square root of a squared cos squared theta multiplied by a cos theta. From this we now multiply with 4 to remain with the area, because we want the area of the circle. So multiply by 4, multiply by 4. This will cancel, then remain with area, which is equivalent to 4b over a, integrating from, now we are no longer integrating from 0 to a, but now to pi all over 2. Remember, a circle is pi, and pi is equals to 360. That's why it is a circle. But now pi all over 2 is equals to 100 and is equals to 90, because we are interested in this part alone. That's why we integrate from 0 to pi all over 2. Then from there now we shall consider a squared multiplied by cos squared theta multiplied by a cos theta. From this we can find the square root and have area is equals to 4b all over a. Then from 0 to pi all over 2, find the square root. This will be a cosine. Now the square root of cos squared is cosine theta, then multiply by a cos theta. This a can cancel this, then we have a, which is equivalent to 4b, integrating from 0 to pi all over 2 of cosine theta cos theta. This a, we can factor it out and it comes here. Now it is d theta. What is this? This is area, which is equivalent to 4ab from 0 to pi all over 2 cos squared theta d theta. Cosine times cosine will be cos squared theta d theta. Because we want to integrate, and there is no way we can integrate this cos squared directly, we shall relate it to the double angle formula of cos squared theta, which is equivalent to a half into 1 plus cos 2 theta. this can be easily manipulated and integrated. Now we shall have a, which is equivalent to 4ab into 0 to pi all over 2. Now instead of cos squared theta, we replace it with a half into bracket 1 plus cos 2 theta d theta. Now we can integrate this before we find the area. Now integrate a half, and here is 4ab, don't forget that, into 1 plus cos 2 theta d theta. When you integrate, this one will cancel and remain with 2ab. Then when you integrate 1 with reference to theta, you will get theta. Then plus, when you integrate cosine, you will get sine. Then it will remain to theta, and divide by the derivative of the second term. That is from the law of integration, whereby when you integrate the first term, you now divide with the derivative of the second term, which is now 2. The derivative of 2 theta is 2. Now we divide by 2, you will get a half. Now plus c. Now this one can easily be now integrated from 0 to pi over 2. Now we have area, which is equivalent to 2ab from 0 to pi over 2 now of 0 theta plus a half sine 2 theta plus c, which is not necessary. Now we start from the upper limit. We replace theta with pi over 2. This will be pi all over 2 plus a half sine 2 multiplied by pi over 2, because we are replacing theta with pi over 2. Then we shall minus with the lower limit, which is 0. Now where there is theta, you replace with 0 plus a half sine 2 0 plus c. This one will cancel automatically 0. Any number multiplied by 0 is 0. Then here, remember, we still have 2ab, which is our area. Now this one will cancel this, and we shall remain with ab. And here, this will cancel this and remain with a half sine pi. Remember, as I told you earlier, 2 pi is equivalent to 360, meaning pi is equivalent to 180. Now here, sine of 180 is 0. A half of 0 is 0, meaning this one will cancel and remain with 0. So pi plus 0 is pi. So our area will be equivalent to AB multiplied by this pi, the only part that is remaining. Now, A from our circle, you remember our circle was this way. Then we had divided it into 4 parts, and we had A to 0, then B. From A to B is just equivalent to the radius of this circle, meaning A is equivalent to B is equals to R. Now the area, replacing A and B with R, you will have R multiplied by R multiplied by pi. Finally, now the area of a circle will be pi R squared. That is the area of a circle. Thank you so much. Subscribe my videos in YouTube. Remember, our target is to locate and find what Albert Einstein never found. Thank you so much.